Hi everyone, my name is Touseef Ahmed. I am a PhD candidate at Kingston Lab at Texas Tech University. And for the Verena, I will be exploring, for the Verena project, I will be exploring how the heat stress bats are involved in viral propagation in the environment. So so my research started because it's because of the Australian flying foxes which were dying in mass number due to extreme heat events. So that triggered my research because I was fascinated how Indian flying foxes in Indian subcontinent are experiencing these extreme heat events because we have more frequent and more intense extreme heat compared to Australia. So I was looking into that thing that lead to my question. So, because I have a veterinary background, so I included the disease aspect, and then I have a conservation question. So the bottom line is how heat stress impact bats and how those heat stress bats propagate zoonotic diseases in the environment. So and we can monitor these bats because through their behavioral changes because these flying foxes have a sequential thermoregulatory behaviors, meaning that they change their behavior um, according to the temperature. So higher temperature have a intense behavior, which I will show you in down in the presentation. And similarly, we can also assess their physiological state, particularly at the hormonal level, to know their stress. So all of these things can indicate, give us a good idea like how much bats are stressed and how they can further contribute or spread or propagate diseases. So because these extreme heat events impact bats and in such a way that it can alter their distribution and abundance. These flying foxes travels, I mean, on a daily 45 kilometer or I think 40 miles, and on a seasonal they can travel up to thousands of miles. So, so this makes a very good case because under extreme heat event they migrate to different places and sometimes they go to the places that they never inhabited because the climate change is pushing the boundaries and now bats are particularly these flying foxes are toward more cooler areas. So that was an interesting thing. And then they are these Indian flying foxes are the most studied animals for zoonotic diseases. We have I mean the research indicate that over 55 zoonotic viruses been isolated from these bats. So that was moving point for me to include disease in my aspect. And then these bats frequently come in contact with humans because their roosting sites are mostly near the human settlements and they frequently come in contact with the water bodies, which are predominant source of many pathogens, particularly in developing countries. So this all create novel opportunities for pathogen to spread. This is an overall design of my current and future research, where we will be monitoring the thermoregulatory behaviors. Then we will be, measuring the fecal cortisol levels to indicate the physiological stress. We will be measuring the food they are eating through molecular dietary analysis, and all of this can give us an idea how much bats are under stress. And then once the stress is established across different roosting sites, which I will show you, then we can predict like how the stress lead to pathogens. And in pathogens, I have done antimicrobial resistance work where we have isolated ESBL E. coli and which were resistance, multi-drug resistance, and that was one part of my proposal. And then with the Verena, I isolated molecular detection of some DNA of adenoviruses. And this is basically a proof of concept study type thing. Okay, and then in the future, I will be more looking into RNA viruses and doing some experimental studies in terms of the micronutrient supplementation to the heat stress bats under experimental or laboratory condition to know which micronutrients are essential to these bats to cope with the challenge of extreme heat. And I will be also developing some models and particularly the forecast, heat stress forecast model for flying foxes. It has been done in Australia, but unfortunately not in Indian subcontinent. So this will inform not only the conservation authorities, but also to the public health, because if the bats dies in number in the environment, then they can propagate diseases. So this is the overall thing. For the Verena, I will be looking more into how the climate parameters, particularly the temperature, relative humidity, and the different thermoregulatory behaviors, and also the land use and land cover, which include anthropogenic source like water bodies or human settlements, how all of these impact the bats and how flying foxes, and how those flying foxes propagate diseases in the natural setting, particularly adenoviruses. So we choose adenoviruses. Sorry, there is a cut here. Anyways, so we choose adenoviruses because to establish a proof of concept, because these are DNA viruses, and as you all know, it's a bit easier, or it's more stable to get the DNA viruses. and and also it also help us to, because I'm a strong proponent of one health approach, so it will give us a lot of idea like how the pathogens are propagating in the environment. And adenoviruses are also, have a role in vaccine development and and antiviral treatment. So all of these inform us an early warning system for emerging diseases, including pathogenic diseases. So one of the thing which I did in this fellowship is the importation of fecal sample, which was a great challenge for me because I never done this before, and there is a lot of permits involved and a lot of regulations in the shipment. And so I came up with all these things, and thanks to the Anna and many people involved in this, making this happen. And we have all these permits, we have all the first-hand information how to bring the samples from a developing country like Pakistan to US. And there is a lot of details goes into what goes inside this shipping box. And I know some of you have done this, but some of you don't, and it's frequent, it's challenging for anyone. This is my study area, where I have 7 different roosting sites that were spread across central and northern regions of Pakistan. These roosting sites have thermal variability, meaning some roosting sites were at higher temperature, some were at the lower temperature, some were in the urban area, some in the rural area, and all of these areas are prone to future extreme heat hotspots. So this gives an ideal system to investigate, the different stress level and different level of the viral or antimicrobial resistance shedding or pathogen shedding in general. So as a study design for thermoregulatory behaviors, we monitor thermoregulatory behaviors in the summer of 2021 for 3 months, from May to August, and it is a 4-day per week, and from 9 to 5 p.m. Every 2 hours, we take the videos of these bats for 15 minutes. So the whole for the 7 roosting sites, we have over 1615 hours of video of thermoregulatory behaviors, and that's give us an idea of how the bats are behaving under heat. And we also have these sensors installed at the roosting sites. These sensors are recording temperature and relative humidity. You can see the values, how they were generating. They were timed to record or automatically take reading at every 15 minutes. So, and the temperature and relative humidity. So this gives us a live forecast of the temperature going up or down, thermoregulatory behaviors going up and down. So as here you can see, these behaviors are sequential. So we have the normal score 1 behavior, which are normal behavior. Then we have a score 2 behavior, which is the wing fanning, start flapping their wings, and then they start clustering, which is they moving toward the middle story of the vegetation. And then this is the stage 4, or the 4 behavior is a clustering behavior, which is a very fascinating animal behavior where the flying foxes are on the tree trunk. And this is I think this is one of the fascinating behaviors in animal. And then after that, they eventually die. And we have those temperature at which they die, but we didn't record it that much death as we were expecting, or as we think because due to several reasons, and we will explain maybe in later. And then here we have for the fecal sample, we collected 1 year, we collected fecal sample for 1 year using non-invasive technique. We have the spread these plastic sheets under roosting sites and collecting 15 to 20 samples per month per roosting site for 1 whole year from June 21 to May 2022. And these were the samples that were selected out of those samples for the adenoviruses screening. We selected 70, and the scheme was 6 sample per season from 6 roosting sites. So this makes 70. Actually made 72, but we were missing 2 samples, so it's 70. And then we extracted the DNA using the Zymos extraction kits. They have all the DNA purification, extraction, all the things in it. So that is it. And then we uses conventional quantitative nested PCR technique. So it's basically it's a 2-round amplification to enhance the sensitivity and specificity, and using these primers of the by the Lee paper, and use the degenerated primers. And so far, in fact, we have just finished our results, and has been extremely helpful in this regard. So we have some positive, which is good news. We just get that news from yesterday, I think. So we still have to send this sample for screening, and we need to do some phylogenetic analysis and all that stuff. But at least we have some viruses, which means that we were able successfully to ship the samples in a cold chain on the simple collections. It really is a relief for me. At least we have 1 or 2 positive, but there are a couple of positive varieties. And again, I will refocus you here as an overall study. It basically, in the future, we will be more looking into the establishing. This project is basically establishing a pipeline for the future molecular investigation using by isolating some or detecting some of RNA viruses, and it will also help better understand how the temperature influence viral dynamic within and in bats, and will enhance our understanding of viral emergence in changing climates. So these are the cool people that were extremely helpful for me. You can see Dr. Anna and my professor, Dr. Tiga Kingston. And thank you so much for listening to me. And this is my team, my amazing team that helped me out this project. There were 8 of research assistants that were spread across the roosting sites, and some were involved in the lab. And I am sitting center with a mask on.